HyperMesh midmesh functionality helps you to quickly derive a mesh from complicated solid geometries. The process is divided in 4 steps: midmesh generation, also called nominal run, cleanup of that result, rebuild the mesh with desired final mesh size, and, last but not least, apply the thickness of the originating geometry onto the mesh. All this functionality can be accessed from the 2D Pages Midmesh panel, the parts browser, or via batch mesher, where multiple parts can be midmeshed simultaneously. The parameter file has been extended with this new option. As a first step, an initial mesh needs to be generated. The mesh size should be smaller than the final mesh size. A variety of options are available to specify the outcome of the final mesh. For example, nearby edges can be suppressed depending on a scaling factor related to the element size, or holes of a certain size can be ignored right away. To clean up the results from the so-called nominal run, the Edit Edge and Edit Face panels can be used. Both panels provide a collection of efficient tools to address potential problems with the midmesh. On the right side of the panel, links to related tools are provided. Edges play a major role in preparing the rebuild of the mesh. They can be introduced in various ways, such as splitting elements with node-to-edge functionality. If the midmesher did not find the ideal path, node lists can be aligned with reference to lines in the initial geometry. T-edges can also be aligned with the surrounding surfaces by just selecting the edge and the surface it shall be aligned to. In a similar manner, faces can be aligned to surfaces. Here an unnecessary edge is removed and the elements smoothened to better represent the geometry. Problematic areas can be quickly identified by the Detect Intersections functionality. It generates sets which can be isolated and further investigated. In some cases, deleting the elements and rebuilding the area works best. In this case, a new edge between specified lines is generated. Once the edges are defined, missing surfaces can be filled, sometimes by one mouse click, or an entire area of mesh can be repaired at once. After the previous step, it's now time to generate the final mesh. The process is based on common criteria and parameter files and requires only the element selection as input. At the end of the process, thicknesses from the solid geometry can be extracted and automatically mapped onto the mesh. After the algorithm generated properties based on the chosen settings, the results can be visualized and verified with 3D element visualization. The midmesh generation process generates a 2D finite element mesh quickly from complicated geometry without the need of deriving a midsurface before.